Hello, everyone. Thank you so much for joining what I guess is the first Breez SDK webinar. We hope to make these webinars a tradition and do them constantly. Today, we're starting with a very diverse audience. We have people listening from coming from different levels of technical backgrounds and coming from some of them actually already are using the Breez SDK. Some of the viewers are new to the Breez SDK. So we'll try to have a session today that accommodates everyone's needs, but it's just a start. So if you feel that you didn't learn what you came here to learn about the Breez SDK, feel free to reach out. We promise that we'll schedule more webinars in the future that will drill down into the technical details of the Breez SDK, or will give you more of a business centric information about the use cases that you can build using the Breez SDK, the applications and the services that you can integrate the Breez SDK into. During this webinar, we'll give you a brief overview of the Breez SDK from a product and from a technical standpoint. Then we'll do a live coding session. Jesse from the Breez team will walk you through building an application, actually building in real time an application using the Breez SDK. So let's hope the demo will go smoothly. There are always issues with demos, so we're hoping that everything will go smoothly in this case. And then we'll make sure to leave enough room for questions and answers, for a Q&A session with both Jesse and myself. So that's the gist of it. You have a chat window on the right side of the software. So if you have any questions, if you have any feedback, feel free to write us in the chat, and we'll pick up on your question either during the presentation or during the Q&A segment that will be towards the end of the webinar. So I guess we are ready to get started. For those of you who aren't familiar with Breez, Breez is we've been doing Lightning stuff, a Lightning product for the past 5 years already. A very veteran Lightning company in the Bitcoin Lightning ecosystem. We actually started with the inception of the Lightning Network back in early 2018. And we've been working to bring Lightning to the masses. Specifically, what we want to do, we want to build interfaces, end user interfaces and developer interfaces that allows people to utilize the peer-to-peer payments that are enabled by Bitcoin. We believe in Bitcoin as a currency. We want to bring Bitcoin to the masses, and we think the right way of bringing Bitcoin to the masses is by providing everyone an easy access to the Lightning Network. And we want this access to be non-custodial access, meaning we want users to maintain their sovereignty while interacting with the Lightning Network. Our existing app that exists both on the App Store and Google Play is the Breez app that maybe some of you are already using. This app is built on the LND implementation. It has several functionalities, several applications built into the Breez app. It of course has a non-custodial Lightning wallet, meaning there's a real fully featured Lightning node that is running on your mobile device when you're using the Breez app. It also contains a point of sale interface. It also contains a podcast player that allows you to stream sats to your content creators. And it contains a built-in Lightning service provider that we brought to market back in 2019. The interesting thing about the Breez app is that we've done a lot in order to improve the non-custodial Lightning experience throughout the years. We invented the Lightning service providers notion. We've implemented channels on the fly creation. We implemented the zero-conf channels. We optimized neutrino. We've done a lot on the technical level to allow users to experience the Lightning Network with less of a hassle. And everything that we've done on the technical level was great for the user experience of Lightning, but it didn't really bring Breez specifically more users or more tractions in terms of the volume of transaction, the throughput that we've processed. But every time we've added a new user interface to Breez, like the point of sale solution, like the podcast player, whenever we added a new experience, a new end user experience to Breez, then we grew dramatically in the number of transactions, in the number of users, and in the overall throughput that we've processed in the Breez wallet. And that's very interesting, because it means that users are finding value in the utility of the peer-to-peer economy. So we basically had a choice. We could have kept on building different user interfaces to the Lightning economy. We could, for example, add a chat or music application into Breez, or we could have, and that's what we ended up deciding to do. We decided to build an SDK, a development kit that every service, every vendor, and every company will be able to use our infrastructure, our non-custodial infrastructure, in order to integrate Lightning payments, either to send a Lightning payment or to receive a Lightning payment to in their experience, in their own applications. Basically, what we want Lightning to be accessible everywhere, and we want Lightning to remain non-custodial. We are not interested in bringing a custodial experience that devalue Bitcoin and obfuscate the value proposition of Bitcoin. We want to maintain the value proposition of Bitcoin when it comes to peer-to-peer transactions, and we want to allow every company, every vendor, and every service out there that is interested in integrating Lightning payment to be able to do so easily without becoming a Lightning expert, using our development kit. And that's why we decided to build a non-custodial Lightning SDK that will allow developers of new and existing apps to integrate Lightning payments into their own services and application without being Lightning experts. Lightning is complicated, and there's a lot to learn, and there's a steep learning curve if you want even to start understand the basic concept of the Lightning Network. What we think should be done in the next evolution, in the next stage of Bitcoin, is to provide developers with an easy access to Bitcoin development without becoming Bitcoin or Lightning experts. And that's why we built the Breez SDK. And the Breez SDK aims to provide it with we take a unique approach. when it comes to interacting with the Lightning Network and exposing interfaces to the Lightning Network. Currently, if you take a look at the ecosystem, you will see various Lightning implementations. You will see LND or LDK or Core Lightning. There are various Lightning implementations that allows you to run a Lightning node. It's very hard and challenging to take this Lightning node and bring it to your end users. You can rather easily run it from a service standpoint, but it's hard if you want to do it at scale and to bring this Lightning experience to your end users. That's one problem. The other problem is that the experience is far from being holistic, meaning running a node is just one pillar from providing a fully featured Lightning experience. What we aim to do with the Breez SDK is to provide an holistic solution and an end-to-end solution that allows developers to provide a fully featured Lightning experience. And that includes not only end user nodes, it includes providing users with liquidity, it includes on-chain interoperability, it includes fiat on-ramps and off-ramp. We'll talk about it in a second. But the approach that we're taking is a different approach to, okay, yet another node. We want to provide an API, which is very simple and seamless API that with one API integrates the various pillars in a single API call. So for example, if you want to send a payment, you just call one API to send a Lightning payment, and the API assembles and integrates all the various components that are needed in order to facilitate this Lightning payment. So we're taking an holistic end-to-end approach when we came to build the Breez SDK. That's one value proposition of the Breez SDK. The second value proposition of the Breez SDK is the fact that it's interoperable. One shortcoming of the current Lightning experience is that the balance is scattered around multiple applications, meaning you don't have the fiat-like experience where you just put your credit card or debit card in an application and the application interacts with the same balance. And multiple applications interact with the same balance across. So you can have, as a user, you can have multiple applications that interact with your same bank account. So when you take an Uber drive or you're paying your Netflix bill, you don't need to top up Uber, and you don't need to top up Netflix, and you don't need to top up Spotify. All of these apps are working with the same regular credit card or debit card or bank account balance. And we wanted to create the same user experience with the Breez SDK. And we'll talk about the Greenlight infrastructure, which is instrumental to providing this user experience. But in a nutshell, we created a hybrid architecture where the node is running in the cloud and the keys resides on users' devices, and multiple applications can run against the same node, and therefore can utilize the same balance from multiple applications. So if you compare the experience that we envision to the experience that we have now in the Lightning ecosystem, where you need to top up Fountain, or you need to top up Stacker News, and you need to top up Phoenix and Breez, and you have multiple Bitcoin balances floating around in various applications, we want kind of to change the paradigm and have multiple applications interfacing with the same node while remaining non-custodial. We'll elaborate in a second. But that's the second value proposition. The third value proposition is the fact that we want to make it frictionless for end users. There are Lightning as a service solutions out there that are custodial solutions, and therefore require a KYC and have AML restrictions. We think that peer-to-peer economy has a lot of value to end users in terms of user experience, meaning it's not just about the ideology behind Bitcoin, it's about practical benefits that end users have when they're using Bitcoin in the pure peer-to-peer form. When they're using Bitcoin in the purest way, meaning they hold their keys, they are not obligated to do KYC, and they are not limited by arbitrary AML restrictions. And you, as a vendor, as a company, you can provide a payment experience that is available across the globe. And you don't need to deal with a specific regional or territorial restrictions if you want to facilitate payments among your users. And that means that the solution is global. We are laser focused on providing developers with the best experience that they can have. We want the integration of the Breez SDK to be effortless, meaning it's literally a few lines of code and you have whatever you need in order to facilitate non-custodial Lightning payments. And I'll say non-custodial once again, because it's another value proposition that the solution is trustless. There's no such thing as trustless 100%. So I would say the solution is trust minimized in the sense that Breez or Greenlight or the LSP or any component that is integrated into the Breez SDK, none of the entities have access to the to users' funds, and users retain full sovereignty. That means that if you're building a solution using the Breez SDK, you can sleep at night, and there's no way that your users will be rug pulled by any third party. So we think this value proposition present a new paradigm shift in the Lightning ecosystem, in the Lightning developer experience, and we can't wait for you to experience that. Practically speaking, these various value propositions also translate to concrete features that you, as a vendor, can provide your end users. One of the features is the fact that we talked about the interoperability, but let's elaborate for a second. All the applications that are written using the Breez SDK are interoperable, meaning you can use the Breez SDK from let's say a Breez wallet app, and then integrate the same keys, add the same keys to a music app or a podcasting app, and then you'll have the same balance, and you will interact. Practically speaking, you'll interact with the same user node across various apps. It also provides you the ability to provide a multi-device experience. So if you want to provide your users with a mobile client, but also with a desktop client, and maybe in the future a web client, it means that the fact that we have an architecture, a hybrid architecture, that the node is running in the cloud, means that you'll be able to provide your users with a multi-device support. The fact that it's a hybrid approach and the node is running in the cloud also means that you have an integrated watchtower, meaning no matter which are the peers that your users are connected to, there is constant watchtower that is running as part of the Greenlight environment that is monitoring the channel, and there's no way that your users can be frauded by the LSP or by other entities in the network. And if we're talking about mobile clients, that can be offline for days and maybe sometimes even weeks. This this is a very important feature in terms of security. The Breez SDK, needless to say, comes with a built-in LSP, meaning you as a service provider, as a developer, you don't need to think about liquidity. The liquidity comes out of the box. On-chain interoperability also comes out of the box, meaning every user starts his Lightning journey somewhere. They can start their Lightning journey with an on-chain transaction, meaning moving from the chain to Lightning. They can start with their journey by buying some Bitcoin using a credit card or a bank account. That's why the Breez SDK also provides a fiat on-ramps and off-ramps. And this is also baked into the Breez SDK. We also provide a fully featured Lightning experience, including LN URL functionality, including seamless backups. There's no need to think about where to store the Lightning state. The Lightning state is saved in the cloud environment. That is integral part of the Breez SDK. Needless to say that Breez is a Bitcoin company, meaning everything that we do is completely open source, completely open under MIT license, and everyone is free to contribute or even fork and reuse the code for their own purposes. Drilling down into the architecture, as I said before, the Breez SDK is not just about providing end-user nodes. It's about providing everything you need, all the components that you need in order to provide an holistic Lightning experience to your users. That means end-user nodes that are facilitated by Greenlight from Blockstream. It means LSPs, which means you don't need to think about liquidity. Liquidity comes as part of the Breez SDK experience. It comes with on-chain interoperability. There's a way to interop with the first layer. Currently, we're doing that by submarine swaps, but in the future, we also add splicing support into on-chain interoperability. And we want to we recognize, and by the way, all the stuff that the Breez SDK includes and comprise of is everything that we've learned as part of developing the Breez application. So in the Breez application, we saw that there's the service that we provide to buy Bitcoin using MoonPay is very popular, and that's why we've added the fiat on-ramps to the Breez SDK. And in the future, we also plan to provide the off-ramps as well. This is a high level, what you see here on the slide, it's a high level overview of the architecture of the Breez SDK. On the left side, you have your client. The client can be a desktop app, it can be a mobile app, and in the future can be also a web app, and when we'll support WebAssembly. The keys resides on the user device. The Breez servers, the nodes, the LSPs, they don't have access to the keys of the users, and every Lightning transaction that is executed needs to be signed by the end user. In the middle, you have the Greenlight environment. The Greenlight platform, the Greenlight cloud infrastructure, provide each user with their own node. And the unique thing, what's special about the Greenlight environment, that the nodes are really performant, meaning they're only wake up when users are receiving or sending Lightning transaction, which makes the entire cloud environment very scalable. And on the right side of the screen, the Greenlight environment is connected to liquidity providers, to Lightning service providers. These Lightning service providers can be either Breez or third-party liquidity providers. We have several partnerships with liquidity providers, including Liquid, and others that we're going to announce soon. And these liquidity providers are integral to the Breez SDK. I want to mention that everything that we do as part of the Breez SDK is very open, and we also always aim to push standards around the various interfaces that we're building. So, for example, when we talk about Lightning service providers, we're a part of a specification group that is building a standard interface under a specific specification that aims to provide users with a standard interface, and that means there's no vendor lock. It means that users can use the Breez SDK and use their own services without even utilizing the Breez commercial services. So you can take the Breez SDK and use it without running the underlying Breez commercial services, the Breez LSP. You can use your own LSP, and you're not vendor locked to Breez. If you want to participate in the spec group, also just drop us a note, and we'll see how we can add you to the group. This is a drill down of the kind of a low-level architecture of the Breez SDK. I'm not sure we'll go over it. We're kind of running out of time, so I won't go over it now in greater details. Maybe if there are questions around it, we can leave it to the Q&A at the end. Again, just to reiterate, we are completely keen to provide an excellent development experience. That's our main focus, and that's our main goal. Our main goal is to make Lightning, our Breez SDK, that simple to be used in various environments. We support a bunch of frameworks and languages already: Go, Rust, C#, Python, React Native, Flutter. But if there is a language that we don't support, and you guys are Python, and you guys are wants to build your experience on top of language or a framework that we don't yet support, just let us know. Jesse will kind of I'll pass over the baton to you. So yeah, take it from here.
All right. We're going to do a demo implementing some code with the Breez SDK. So what you see here is my screen, and we're creating an app. I know that this could be any app that you're creating. Your app will be focused on UI and functionality, and you'll be implementing Lightning payments just as a part of your app, or you can create a real Lightning wallet app, for example. I'll just show you what we can do with this app. It's very simple. You can receive, and it will show you an invoice. And we can call send, and then we can paste an invoice in here that we will pay. That's basically the functionality of the app we are creating. And currently, this is just a UI, so there's no Lightning integrated in here yet, and I will walk you through how to integrate Lightning payments into this application. We're doing this live, so it will definitely be able to break, but we'll see what happens, right? So first of all, I'm going to add a dependency to the Breez SDK. So this is a Flutter app, by the way. I've got Breez SDK repository cloned, and I've got it on my local file system, and I'm adding that now as a dependency so I can use the SDK here. And then what we first have to do is we're going to have to create a node. Or maybe the user doesn't have a node on Greenlight yet, and maybe it does. We'll have to make sure that the user is connected to a Greenlight node. And I'm going to replace this piece of code over here in the main app with some code I already created beforehand. And I'm going to walk you through it, like how do you connect to the user's node? Because yeah, you have to think about, you could think about the user might have multiple apps that all include the Breez SDK, so he could have, yeah, he has the same balance on all these apps, so you're connecting to the same user node basically. I've got this example code on GitHub too, and we've also got very good documentation on how to get started with the Breez SDK. I will share the link afterwards too. So basically, I've got some logging over here. That's not very important, but here's the important part: start SDK. What we're first going to do is we're going to check our secure storage on our local device, whether we already have a mnemonic stored. And if we don't have a mnemonic stored yet, that means the user has never started this app before, and he has to create a new node on Greenlight. So we generate a new mnemonic, and we write it to secure storage. So we're about to initialize a brand new node then. We could already have a seed stored locally, and then we're going to reuse that. Then we're going to create some configuration to how to connect to the SDK. We're going to use the production configuration. We're going to pass an API key to use the Breez liquidity services. And we're going to add some configuration for Greenlight, which is the infrastructure provider for that's hosting the node. And we're going to pass a Greenlight invite code here. An invite code maps to one node of a user. When you go to production, then you will get a partner certificate, and you'll be able to create certificates for the user, so you don't have to like paste an invite code in here. And with this configuration, we're going to first, this is a Flutter specific call over here. It initializes some Flutter bindings, so we can react to calls from the SDK. We'll see some of those calls later. And here's the main call that connects to the user node. So we call SDK, and we've got an object here called SDK. And everywhere where you see SDK dot, that's where we're actually connecting with the or communicating with the Breez SDK. So that's good to know. SDK.connect, we pass our config and our seed, and that is going to actually connect to our node in the cloud. So that's for setting up the node. Let's talk about receiving a payment. I'm going to copy some code over here. So we've got a receive dialog. We've got a receive button here. And currently this invoice is just a random string. And we want to make sure that this invoice actually comes from our node and is the actual one, to actually be able to receive a payment. So I'm going to replace this with some code to call the SDK. Let me add some dependencies over here. Yeah, the dependencies will probably come later. I'm going to first show this little piece over here, and then I'll go up here. So we call SDK receive payment. And then with an object like how much do you want to receive? Over here, we're just going to receive a fixed amount of 10,000 sats. And we've got a little description over here. This is going to create an invoice for us. Then when this call completes, then we're going to update our UI. We're going to set the invoice, which is going to actually translate to the QR over here. And a little payment hash over here, which we're going to need later. And for error handling, I just print to the console over here. I bet you're much better at developing apps than I am. So that's for creating an invoice. And then we're going to listen for this invoice to be paid. So we've got an invoice paid stream over here. And we're going to listen to it. And if this is our payment, that's our invoice that's being paid, then we're just going to pop this screen and go back to the main screen. Yeah, so that's all you need for receiving a payment, basically. So you call a function, receive payment, and then optionally, you can listen for the invoice to be paid in order to give the user some feedback that he got paid, actually. So let's save this. Going on to sending a payment. Notice that this code is pretty small, so that definitely helps. You can focus on your UI, you can focus on your functionality, and you don't have to worry too much about internals of payments. You can just call a function, receive payment or send payment. We're going to the send dialog, which is this one over here, which is very bad UI, but it will work. So you can paste an invoice over here, and when you press OK, then we're going to pay that invoice. So on the OK button, on pressed, what we're going to do is call a function. We'll call the function. First, we're going to update our UI with a little loading spinner. That's what this line over here does. And then we're going to call send payment to whatever text is in this box over here. Then when the payment is sent, then we just pop the route and we go back to the main screen. That's what this means. And on error, we just print something to the console. Got something in the throat over here. So that's for sending a payment. This is basically a function called send payment. And that's got all that you need. I'm going to go to the balance. I'm just going to go walk through all this code quickly, and later we're going to do the actual demo, run the code, and then you'll see what actually happens. Because over here, in this screen, you've got a little balance. We've got a widget for this balance, and it's currently showing -1 set. So we've got -1 sets available, and that's fortunately that's not possible in Bitcoin. That's because I've set it to -1 over here. We want to set it to the actual balance. So what we can do is listen to the node state stream, and whenever there's an update to the node state stream, we're going to update that balance to whatever we can pay. So that's the balance we currently have. So whatever we can pay, that's our balance. This is in millisatoshi, so we divide it by 1,000 to get satoshis. So we've implemented now receiving and sending and showing the balance and setting up a node. So if everything is correct, that means that we're now able to run this app and actually, give the user a little bit of a lightning experience. That wasn't too much time to do that, right? I just need to compile this app now, which always takes a little bit longer on my machine for some reason. So when the app runs, I'm gonna show you what we're doing again with the code on the side, and we'll see how that works. Maybe in the meantime, I can just answer a question that someone has while I'm compiling. Let me see. How much does it cost to integrate the SDK on an app, let's say, that has 100 million users and a wallet of 10 million users? Is it going to be one-off plus subscription-based, monthly cost based on the number of transactions? Maybe that's a good one for Roy to answer, isn't it?
Yeah, well, you picked up on the business question there. Yeah, Laura, thank you for your question. So our business model is actually a B2B2C model, meaning our revenue stream comes from Lightning transactions, meaning from the LSP service that we provide. So we are taking a cut from Lightning fees, and these Lightning fees are being paid by users. That means practically that developers, companies, vendor services that integrate Lightning payments, they don't have any additional cost. They can just integrate it for free. We don't expect any monthly service cost from companies or vendors, unlike other services in the market, and that's because essentially the Lightning transactions are not executed in a custodial fashion. They're executed in a non-custodial fashion, which means that the end users are paying for the Lightning fees, and we expect to take a cut from this Lightning fees because we're powering this entire platform by providing a Lightning service provider, by providing liquidity services to end users.
Nice explanation. Yeah, so the app is almost completed loading. Maybe we can answer another question.
Sure. Let's pick up on Eric's question. When setting up a node, how can one check if another app is already using the Breez SDK? I assume users would have to import the seed onto next app. Is that correct? Yes, Eric, that's correct. So in order to use the Breez SDK, the same node of the Breez SDK for multiple applications, users will have to use the same seed across multiple applications. There are two, in order to understand that there's another app that is using the Breez SDK, so we will provide you with application-specific backup data. So for example, as part of the APIs that the Breez SDK provide, you'll have application-specific data, and you will be able to set an application-specific data in your application, and by reading this data, you will be able to kind of do your own heuristics on your own logic. That's one thing. The other thing is that we're planning to improve the share experience. So we want to provide an integrated share experience to the seed, meaning you as an application developer, you'll be able to present a share button, and using the share button, all the other applications that supports the Breez SDK will be able kind of to register to the underlying share platform, and that will facilitate easy sharing of seed of mnemonics from one app to the other without the user having to copy paste or type in their mnemonics.
Nice. So in the meantime, the app finally started, so my machine still works. It's good to test this on low-end devices. So what you saw over here is that the balance updated to 0 set. And that means that we've actually initialized the node on green light now. And you also see this in the logging over here. It's like it's the first run. And we're actually communicating with the node a little bit, initializing a signer. Yeah, basically doing some stuff to communicate to the node, and that's how we got our balance as well. So if we go to balance.dart here, you see that widget. It just listened to the node state stream and updated the balance based on that. So that's how we got this balance over here. So now we go into receive a payment, which is, I guess, one of the bigger magics that we created. So now we actually communicated with the node to create an invoice. That's why we show this nice invoice here. And I can pay this invoice with my phone. This is mainnet, so I guess anyone could have paid this invoice. And now you see that we've actually received the payment already. So it's what just happened here is the sender, this is me, sent the payment, but we didn't have any Lightning channels yet. So under the hood, the app or the Breez SDK requested the Lightning channel because he didn't have enough inbound liquidity to receive the payment. And then when the payment was sent, on the fly, the Lightning service provider opened the Lightning channel to our user node, which is hosted on Greenlight. In order to do that, to open the channel and actually receive the payment, a lot of stuff had to be signed. A lot of messages had to be signed, and they were all signed on this device locally, and nobody else was able to do that. And then when we've actually got the channel, the payment was actually forwarded, and we received the payment. It was a payment for 10,000 sets, but we received 7,500 sets. That's because the LSP takes a fee when you receive a payment where you need an inbound channel for. You have to pay for the channel if it's being opened. So that's what happened. Let's send a payment too. So I'm going to create an invoice on my phone for sending a payment, just to show you how it's done. Let's do 100 sets or something. And send that to my computer. As you see, I am not the one creating the pretty UIs. I totally depend on you guys to do that because. Okay, so I going to paste an invoice over here and press OK, and that should send the payment out again. I'm going to just send dialog in the meantime, which is basically calling a function send payment. And the rest of it is focused on UI, update of the UI, show the loading spinner, all these kinds of things. And I received the payment on my phone for 100 sets. So that's all you need in order to integrate Lightning payments into your applications with the SDK. So I think this becomes really, really easy, and you can really focus on development of your apps and not worry about payments too much, because SDK takes all of that out of your hands. Yeah.
Perfect, Jesse. Thank you so much. I think you demonstrated the magic of the Breez SDK. I think it's an unparalleled experience to what current solutions has to offer, and most importantly, everything is non-custodial. So we are focused on bringing the non-custodial Lightning to the masses, and I think with our solution and integrated with the Greenlight environment, I think it's a huge step forward. And the future that we envision, the future that we would like to see, and we're actively working to bring it to reality, is having dozens, hundreds, and thousands of apps integrated with Lightning payments experience. So thank you so much for the demo. And maybe we have exactly 10 minutes left. Maybe we'll move to the Q&A session.
That sounds good. Let's pick out some questions over here. I'm just going to start on the top. There were some good questions on the top as well. Omar asked, can you talk more about liquidity services? I wonder. I think we've.
Yes. Let's review the liquidity service in a nutshell. Liquidity services are provided by the concept of an LSP, a Lightning Service Provider. By default, when you use the Breez SDK, you are pre-configured with the default LSP. It can be the Breez LSP. It can be a different LSP that you as a vendor chooses. And you can even create a dynamic experience where end users they choose their Lightning Service Provider, meaning it doesn't have to be completely obfuscated from end users if you decide to kind of expose this decision and to delegate the decision to your end users, meaning your end users are also can also decide on the liquidity service that they choose. And as I said during my segment is that everything is built on top of a standard interface now. We've been working with companies like Synonym, C equals, and others to create a Lightning Service Provider specification, a standard specification, exactly like the Bolt specification. It's an open specification process where everyone can contribute to, and that makes everything interoperable between Lightning Service Provider, meaning it means that if you're using the Breez SDK and Breez SDK implements a standard interface, you'll be able to choose any liquidity service that adhere to the standard, which is great.
Yeah, very nice. Okay, let's go to the next. All right. No, click this one. Would this mean that the Breez SDK allows users to maintain custody of their funds in a mobile wallet whilst allowing features like Lightning address?
Excellent question, Peter. Excellent question. What I want to note is that the fact that we're using a cloud node environment doesn't mean that we solve the offline payments issue of Lightning. By the way, I'll do a session about offline payments in the Bitcoin Honey Badger conference in Riga. So if any one of you is planning to join us at Riga, make sure to be at my session there. I'll elaborate about offline payments and various solutions. I want to mention that we're currently actively working on the ability to receive offline payments using mobile notifications, meaning if you run the Breez SDK in the context of a mobile application and the mobile notifications will be on, you'll be able to receive offline payment. And that means that you can add another layer of a Lightning address on top of it to support Lightning addresses in a non-custodial fashion. And that's also going to be a huge step forward. Another thing I want to mention in this context is that as an industry, as an ecosystem, we're working on an asynchronous payment standard that involves a few Bolt specifications, and we're hoping to have asynchronous payments baked into the protocol, the Lightning protocol itself, and that will completely solve the offline receive problem. And then it means practically that you'll be able to provide Lightning addresses to your users, no matter if they're on mobile, desktop, or web.
Exactly. Yeah, so it sounds nice also to have a Lightning address and make it easy to get paid because you can just tell someone your address. But yeah, there is a problem that you have to be online in order to receive the payments. So even though the identifier looks nice, there's a lot of infrastructure involved too, and also domain names. You said it was non-custodial in order to receive on a Lightning address, but there's also always a little bit of you need to have a domain name in order to host a Lightning address.
It's still non-custodial. There's always trust when the web is involved and IPs are involved, but the users still maintain full custody over their funds.
Yeah, that's true. Yeah, exactly. Okay, let's go to the next question. How many transactions per second can you handle, and with what success transactions rate?
So are you asking? It's an interesting question, but I'm trying to understand whether it's from an end user standpoint or from a service standpoint. I don't think there are theoretical limits of the Lightning architecture itself is limited by the amount of transactions that the channel can process. I think there are the answer varies based on the specific Lightning implementation. Greenlight is using CLN. CLN can process hundreds of transactions a second per channel, if I remember correctly. So I don't think there's an issue to process large volumes of transactions. The success rate more depends on the entire Lightning ecosystem, the liquidity within the Lightning network. We're still at the stage where payments up to kind of $1,000 are processed quite easily, but large payments above $1,000 are kind of struggling. Breez, as a Lightning service provider, has over 95% payment success rate. So that's I'm trying to give you kind of a sense of what you can expect.
Yeah, and it's good to mention also that if you're running your own Lightning node and on your own infrastructure, then you've got your signer right next to your node, right? So that is the best performance, let's say, in order to receive Lightning payments. In this case, the node is in the cloud and your signer is locally, so there are some round trips there to in order to sign messages. So it's not the absolute most performant way to run a node, right? If you are able to run your node in yourself, then you could definitely have more transaction throughput that way. But I also don't think there's any limitations for an end user to receive and send payments. It should be very quick. That's just okay. Let me see, what questions do we have? Another app, we've already answered that. Oh, yeah. Oh. SDK for JavaScript.
Yeah, so we support. Yeah, we support currently from a web development standpoint. We support React Native, which is kind of JavaScript, but requires React Native, of course. We are planning to support WebAssembly. So I think we're focused on mobile and desktop and server applications right now. We have NPM packages for React Native. I don't think we'll support pure JavaScript until we'll support WebAssembly integration, and that's towards the end of this year.
Does the SDK provide fee information to the app for cases like LSP opening channels? The answer is yes.
Yes, the answer is yes. There will be links at the end of the webinar pointing to the Breez SDK documentation, and there's an LSP information object. The LSP information object provides all the fee information. There's also a new feature that we implemented called dynamic fees, meaning when every time you're trying to receive a payment, you can know at that time in real time what's the fee, what's the LSP fee going to be.
Yes. Yeah, is it possible to use testnet?
Unfortunately, no. At this point, we're focused on the mainnet environment, and the reason is that again, there are multiple pillars to the Breez SDK. It's not just about there is a testnet environment to Greenlight, but then you need an LSP with a testnet environment, and you need submarine swap services that are working on a testnet environment, and you need fiat on-ramps that are working on a testnet environment, meaning it's not a single component that we need to provide a testnet environment for. So our recommendation at the moment is to just test the application with a small amount. Going forward, we do want to implement the testnet environment, but testnet is challenging because of the characteristics of a testnet environment. A testnet is kind of clunky as it is, so we need to focus on that. And if there will be demand, we'll provide you with a testnet environment. One last question, maybe Jesse, because we're running out of time.
Yeah. Where are the Greenlight servers hosted and by whom?
The Greenlight servers are currently hosted in the United States by Blockstream. We are working on a European-based hosting solution that will come in the upcoming month. I want to note that in our agreement, in our partnership agreement with Blockstream, we made sure that you can self-host the Greenlight environment. Meaning, if you want to self-host your node, you can do so as well and integrate it with the Breez SDK. Thank you so much for everyone that joined the webinar. We'll make sure to follow up with the unanswered question with you specifically. Feel free to reach out to us in the various communication methods, Twitter, X, whatever it's called now. You can join our Telegram group, Breez_Lightning. You can contact us via our website, breez.technology. You can reach out directly to us. Both Jesse and I have an online profile in Nostr, Twitter, etc. So feel free to reach out to us directly. We hope to make this webinar a tradition. So thank you so much for being part of the inaugural webinar, and we hope to see you in our upcoming webinars as well. I want to thank Ivan from the Breez team for setting the infrastructure behind running this webinar, and I hope that we brought you some value. Thank you so much.